Hi, welcome back. In part one, we talked about this step-by-step process of this U substitution. In part two, we saw a couple of examples of using this U substitution process, but then we had this loose end to tie up. We started this example at the beginning of the first part, and we weren't able to finish it. So I want to remind you what this example was. We had a marginal cost for a company producing X units of a product. Our MC for marginal cost equals 60 times the square root of 2x plus 1, and the fixed costs are $340. And our job is to find the total cost function. And so where we left off was we had written down that marginal cost, which is another name for our derivative, is our 60 times the square root of 2x plus 1. So if we want to find the total cost function, that means we want to find the antiderivative of the marginal cost function. So we want to have the integral of 60 times the square root of 2x plus 1 dx. Okay. Now, when we started this problem, before I paused it in part one, we had rewritten the square root as a power, so we have the integral of 60 times 2x plus 1 raised to the 1/2 dx. And this was where we stopped. And the reason that we stopped is that we had fancy stuff raised to a power. But now, when I look at this integral and I see fancy stuff raised to a power, what this tells me is that I want to use U substitution. I want to do a U sub. Okay, so let's work through the work to evaluate this integral. So I'm going to write the integral up here. I have the integral of 60 times 2x plus 1 raised to the 1/2 dx. And over on the side, I'm going to do my work to choose my U. Now, I do have to watch out because one of my assistants is taking a nap down here on the floor. The other assistant is watching from over on the side. Hi, Franklin. Midnight's down here. So the work that I do off to the side, without stepping on Midnight, is I start by choosing my U. And so in this case, the fanciest part of this function is the 2x plus 1 raised to the 1/2. So I choose the inside stuff to be the U value. So my U will be 2x plus 1. And I'm going to want to remember that, so I'm going to circle it. My next step is to take the derivative. The derivative of U we write as du over dx. And the derivative of 2x plus 1 is 2. Okay, once I take the derivative, my next step is to solve this equation on the side over here, solve this equation for dx. So I'll multiply both sides by dx, which leaves me with du equals 2 dx, and then divide both sides by 2. And so what I end up with is dx on the right side is equal to du over 2. Now, this is about our fourth example of a U substitution, and you might be starting to see a pattern here. For example, when you start out and you have the du over dx equals 2, and then you solve for dx, what you're doing is putting whatever was on the right side under the du and putting that dx on the right side. So this whole piece can get shortcutted, but I would recommend writing it out for at least the first 25 to 50 of these problems that you do. Okay, so we've done all of that work over on the side. After we have solved for dx, our next step is to do some substitutions. So the first substitution we make is we replace the 2x plus 1 with u. So we have the integral of 60 u to the 1/2. And the second substitution that we make is that we replace dx with du over 2. So we have times du over 2. Okay, now in most of the other examples, in fact, all of the examples we've seen up until this point, we've had some x's in this denominator that we've needed to cancel. Right now, this integral is entirely in terms of u already. So that's good, but we can still clean it up. So for example, I have this 2 in the denominator. I can push it to the front so it joins with the 60. So I have the integral of 60. The 2 is in the denominator, so it's got to stay in the denominator. So I have 60 over 2 u to the 1/2 du. And I can clean up that 60 over 2. 60 divided by 2 is 30. So I have the integral of 30 u to the 1/2 du. Okay, so I've now cleaned up this integral. I am ready to find the antiderivative. So now we find the antiderivative. And I will say that this step right here is one of the most important steps and one of the most often forgotten steps. People will do all of this work and get to the point where your integral is all cleaned up and entirely in terms of u and forget to find the antiderivative. The whole point of this whole process is to be able to find an antiderivative. So let's do that. So finding the antiderivative, I add 1 to the power. 1/2 plus 1 is 3/2. And I divide the number in front by the new power. So I have 30 divided by 3/2. U to the 3/2 plus C. Okay, so I can type this 30 divided by 3/2 into my calculator. That's all fine. If I do that, I should end up with a value of, so 30 over 3/2, 30 times 2/3, because when I flip and multiply, I get 60 over 3, which is 20. So I have 20 u to the 3/2 plus c. Okay, now that I have taken my antiderivative, now I can substitute back in for u, and so what I have is 20. My u, let's see, it's a good thing that I circled it over here because I might have lost it otherwise. My u is 2x plus 1. So I have 20 times 2x plus 1 raised to the 3/2 plus c. And this is my total cost function so far. So we've done all of the work to find our antiderivative. And so this is our total cost function, but then we have a plus c at the end. Okay? So we need to figure out what that plus c should be equal to. And there's one piece of information we have not used, and that piece of information is that we were told that the fixed costs are, let's see, we said $340. And when we talk about fixed costs, that means the cost of producing 0 units. These are the costs incurred by renting the building, buying the machinery, things that you need to do before you can even start producing any sort of product. Mathematically, what that means is that the cost to produce 0 items is $340. Now, every example up until now, you've said, oh, well, the fixed cost is whatever that number is at the end. And I warned you, I said, be careful, because when our functions get fancier, this method of just tacking on the fixed cost at the end may or may not work. So let's think carefully about this. Our fixed costs are $340, meaning the cost to produce 0 items is $340. If I plug 0 into my function up here, I'd have 20 times 2 times 0 plus 1 raised to the 3/2 plus c. And that had better be equal to, that whole thing, had better be equal to $340. So let's clean this up and see if we can figure out what c should be equal to. Well, 2 times 0 is 0 plus 1. So I have 20 times 1 raised to the 3/2 plus c. 1 raised to anything is 1. So I've got 20 plus c is equal to 340. And so if I subtract 20 from both sides, I end up with C is equal to 320. So my plus C up here is not the same as my fixed cost, it's this value of 320. So my final answer is that my total cost function is 20 times 2x plus 1 raised to the 3 halves plus 320. Now, if you plug 0 into this function, your output will give you 340 because this first part won't be 0. But my point is that this last value is not the fixed costs in this example. Okay, so our final answer is we have our total cost function, and we found this total cost function by finding an antiderivative. Finding that antiderivative required that we do a u substitution, so it was a little bit more work. Once we found our antiderivative, then we used our extra piece of information to figure out what that plus c should be. All right, that's all for now. Thanks for listening.